Greetings to the freshers. I welcome you all to SIET family and I congratulate you for choosing the program EVLSI for your graduate studies. This subject is going to make you a demanding human resource not only in India, all over the world because VLSI design is growing at very high speed. So I am Dr. Bindu Salim. I will be teaching a subject, namely electronic devices, which is one of the core subject which you should know once you grow as a VLSI designer. You must be thinking what would be electronic devices. You would have already studied little bit about electronic devices in your school, but here you have to study the devices much more deeper. So before going to what all you have to study, I wish you to look at a small video.
Simple circuit consists of the same basic parts. It has an energy source, a battery. It has an output device, in this case a bulb. Wires, usually made of copper, are used to connect the circuit components together. Simple circuits often include a switch, which controls the flow of electricity as it opens and closes the circuit. This is how the components in a simple circuit can be assembled. When the switch is in the off position, there is a break in the circuit. There is no complete path along which electricity can flow, and the output device, the bulb, does not light up. When the switch is in the on position, there is a complete path along which electricity can flow, and the bulb lights up. How do you think adding another bulb to the circuit will affect the brightness of the bulbs? You'll find out in the next video.
So you have seen a simple circuit. I would say a symbolic circuit. So a circuit is something which consists of a source of energy. There could be a switch, there could be several switches, there is a load. So we can say a source, a load, and the source is connected to the load through a switch. The switch can be opened or the switch can be closed. When the switch is closed, the source will send a current. The current will flow like this. It comes here, it goes through the switch. Switch is closed, then the current will flow through the load, which is a bulb in this example. The bulb blows, the lamp blows, and the current will end at this point. So this is called as a circuit. Okay, you know the meaning of circuit. So in this circuit diagram, you should know a circuit should have a source, power source, there should be load, and in between the source and load, there can be elements. In this picture, there is only a switch. There can be several electronic devices, electronic components in this. So let us see what is this source. So here I said it's a symbolic representation. A source, we know where do we get power from. We get power from the generating station, and it is AC. So the devices which or the load which we have need not always work on AC. So this AC has to be converted to DC. So here is some circuit which is called as a rectifier, and you can find there are electronic devices here. So you should know what is an electronic device. Diode is an electronic device. Further you go, you find electronic components which you are familiar, capacitor and resistor. Then here is something which is slightly different from this diode. This is a special diode. This is an electronic device which is called as Zener diode. The Zener diode will help us to convert the DC voltage generated by the rectifier to a perfect DC without any fluctuation. So This is, you understand what is an electronic device. So we need electronic devices to manipulate with the power source to convert it into DC. AC can be converted to DC. So diodes are required, Zener diodes are required. This is just an example. Coming to the switch, this is a mechanical switch. I mean, there is a lever. If you lift it up, physically you should lift it up, then there will not be any path between this end of the switch and this end of the switch. We say switch is open or we say switch is off. Once you put the lever in this position, there is a path between this terminal and this terminal, so it is called as a closed switch. So this switch can be of different types. Here I am giving you a small example where this is a circuit which consists of a transistor. This is another electronic device, very very important electronic device. There are electronic components, resistor, one variable resistor here, there is a fixed resistor here, and this is a light dependent resistor or a light detector, or we can call it as a optical sensor. It's connected here, and there is a different kind of diode which is a light emitting diode. So when light falls on this diode, this is a light detecting diode, the resistance of this diode varies, and which will allow current to flow through this path. When the current flows through this path, this LED glows. So this is acting as a switch. This is the source, and there are so many electronic components in the circuit helping this device to act as a switch. So now you would have understood more clearly. In any circuit, there could be source, there could be load, there is a source, there is a load, and there are some circuitries which can control whether the source is able to supply the load. So the source itself could contain several electronic devices like diode, transistor, etc. Special diodes like Zener diode, and the switch can be made up of simple electronic circuits, or it could be very complex, like how many switching is happening in your mobile phone, how many switching is happening in your computer. All these are electronic switches. So we will be studying much more as you grow to second semester, third semester, and finally when we become a VLSI designer, you will be very clear about all these things. So try to understand what is an electronic device. So LDR is an electronic device, LED is an electronic device, transistor is an electronic device, and we have seen diode is an electronic device, Zener diode is an electronic device. So with this, I think we will just try to know what all you will be studying in this program. So here we have defined the course objectives. Someone will ask you, what was the objective of the course electronic devices later, when you are in third year or fourth year, when you appear for an interview, what were the objectives? So you should be clear what all the objectives of a particular course when you study. So this course is making you understand, analyze and apply a PN junction diode for various applications in forward and reverse bias conditions. To understand and analyze special diodes, as I just now told you, Zener diode is used for specific purpose of voltage regulation. There are some diodes which can generate microwaves. You know, you must be aware of microwave because you have microwave oven in your home, and all our communication is through microwave. Then to understand transistor, bipolar junction transistor and junction field effect transistor, thoroughly knowing the how do you bias it, how how will the characteristics of these devices will be in response to an input. The fourth course objective, you should know how do we model. You know, modeling means how we mathematically represent a device. So how you model a transistor or diode or any other device, which will enable you to understand how to use computer aided design tools because modeling, we have to give mathematical equations to computer aided design tools, which will make you understand how the devices work. Further, you have to study or understand some power electronic devices like Shockley diode, SCR, thyristor, diac, UJT, then some display devices like LED, LCD, optoelectronic devices. These all, plenty of numbers of these devices are being used in all the devices which you have in your hand, your mobile phone, your watch, your computer, uh, your television, your refrigerator, your washing machine, your dishwasher. Everything has got all these devices to make your work easy. So with this, I will just show you the topics which you have to study. There are 5 units for the subject. Starting with semiconductor diodes, we will be knowing that doing the analysis of the device, followed by special diodes like Zener diode, breakdown diodes, varactor diode, gun diode, tunnel diode, and transistor, which is a very very important device. You will be knowing how to model a transistor. Then some power electronic devices like thyristors, SCR, uh, LEDs, LCDs, optocouplers, phototransistor, etc. Most importantly, why I showed you the syllabus is to make you understand the textbooks referred. I mean, the textbooks are two. One is Electronic Devices and Circuits by Salivahanan. That is your first textbook. So that book will contain all the syllabus. You must be getting that book from the college. Then Nieman, Semiconductor Physics and Devices, you have to refer. Followed by Boylston. Boylston is a very good book which even I have been reading when I was a student. Uh, then textbook of Applied Electronics by Seda. Fundamentals of Semiconductor Devices, McGraw-Hill, by McGraw-Hill. The author is Yang. With this, I wish you all the best, and please balance your studies. Be responsible. Unlike what you do in school, you are required to read textbooks. Teachers will be just a guide for you to understand what all you need to study in a particular course, and it is your responsibility. You study more. Uh, you have to study more to fetch higher marks. You have to become designers. Your critical thinking capabilities are to be improved. So, with this, I wish you all the best. Thank you.